All right, welcome to the Explainer. Today we're getting into something you've probably used a bunch of times without a second thought. Wood glue. I mean, it seems so simple, right? But the science behind how it actually works is, well, it's pretty amazing.
So let's just jump right in. This is really the big question, isn't it? How can this simple liquid create a bond that's actually stronger than the wood itself? When a glued joint fails, a lot of the time it's the wood fibers that rip apart, not the glue. How is that even possible? What's the secret sauce?
Well, to figure that out, we have to zoom way, way in. I'm talking microscopic level. Turns out, all that incredible strength really boils down to two main secrets of stickiness.
Okay, so at its core, glue works in two totally different ways. You've got what's called mechanical bonding. Think of that as the physical side of things. And then you have chemical bonding, which is all happening on a molecular level. And this is a great way to picture it. Mechanical bonding, it's basically like microscopic Velcro. The glue seeps into all the little nooks and crannies, the pores of the wood, and then it hardens, physically locking everything in place. Chemical bonding, on the other hand, that's more like millions of tiny, powerful magnets. The molecules of the glue are actually forming these super strong chemical connections with the molecules of the wood. Now, for a joint to be truly strong, you need two things to happen. You need great adhesion, that's the glue sticking to the wood, but you also need great cohesion, that's the glue sticking to itself. Think about it. If the glue holds onto the wood, but falls apart in the middle, the whole thing fails. Both have to be rock solid. All right, so here's the deal. It's not just about squirting some glue on and hoping for the best. Crafting that perfect bond is really a system, a team effort between three critical things: the glue, the wood itself, and the way you put them together. Let's dig into that. First up, the glue itself. It has to have just the right properties. It needs a low viscosity, which is just a fancy way of saying it has to be runny enough to soak into all those wood pores for that mechanical grip we talked about. It also needs low surface tension, so it spreads out in a nice thin film instead of beating up like water on a waxed car. This wetting is absolutely crucial for getting that maximum chemical bond. Next, you've got the wood. The condition of the surface is a huge deal. It has to be clean, obviously, but you also want fresh cuts to expose new wood fibers. Any dust, oil, or resin is going to get in the way of a good bond. And get this, even the moisture content of the wood has to be just right. Too wet or too dry, and you're in trouble. And finally, there's the technique. How you actually join the pieces is critical. You want a thin, even coat of glue, not too much, not too little. Then you got to apply good, firm pressure right away. That clamping isn't just to hold it in place, it's to force the surfaces into super close contact and squeeze out any air bubbles. And then you wait. Every glue has a cure time, and you just have to let it do its thing. Okay, so we've got our perfect liquid glue. It's seeped into the wood, it's coated the surface, but it's still a liquid. So how does it go from being wet and gooey to a solid bond that's tougher than the wood itself? Well, this magic trick, this transformation, really happens in one of three main ways. And knowing these three methods is the secret to picking the absolute best glue for whatever you're building. So first up is the most common one, evaporation of water. This is how your everyday white and yellow wood glues work. The actual sticky stuff, these things called polymers, are just floating around in water. When you spread the glue, the wood acts like a sponge and just soaks that water up. As the water disappears, the polymer chains get packed closer and closer together until they tangle up and lock into a solid mass. Pretty cool, huh? Method number 2 is the evaporation of a solvent. Think of things like contact cement. Here, the adhesive is dissolved in a chemical solvent, not water. You spread a thin layer on both pieces, and then you wait. As that solvent evaporates into the air, the glue gets incredibly tacky. Then, the moment those two surfaces touch, bam, it's an instant bond, no clamping needed. And the third method is the real powerhouse, a chemical reaction. This is the world of two-part epoxies. You have a resin and a hardener, and you mix them together. That mix triggers a chemical reaction, where the molecules start linking up, building brand new, super strong structures. It's not just drying, it's creating a whole new solid material from scratch. That's why it's so strong and great at filling gaps. All right, with all that science under our belt, let's take a tour of the modern woodworker's toolkit. All this stuff we just talked about is what's going to help us make sense of that giant wall of glues you see at the hardware store.
This little chart here is a super handy guide. You can see right away how something like standard white glue, which hardens by water evaporation, has lower water resistance and is perfect for indoor stuff. Then you look over at epoxy. It hardens by a chemical reaction, it's totally waterproof, and it's built for those heavy-duty structural jobs. It's all about trade-offs.
So, what's the bottom line? What does this all mean for your next project? It's simple, really. It's all about picking the right glue for the job. So if you're doing most general indoor woodworking, building a cabinet, fixing a wobbly chair leg, your go-to is going to be a standard PVAc glue. That's just the technical name for the white or yellow wood glue we all know. It's strong, it's easy to clean up with just water, and it's perfect as long as it's not going to get rained on. But what if you're building something for outside, like a picnic table or an outdoor planter, or something that has to hold a ton of weight? Well, that's when you call in the big guns. Polyurethane glues and two-part epoxies are the champions here. They're incredibly strong, totally waterproof, and they're exactly what you need when the going gets tough. And of course, there are the specialists for very specific jobs. You've got Cyanoacrylate, which you probably know as superglue, for those small, lightning-fast fixes. And then there's stuff like hot melt glue, which you see in factories for things like attaching the edge trim on furniture, where they need a decent bond, and they need it now. So really, the most important thing to remember from all this is that a glue joint isn't just sticky stuff holding two pieces of wood together. It's a complete system. The glue actually becomes one with the wood, creating a brand new composite material right there at the glue line. And that is why the wood itself often gives up before the glue does. And all this kind of makes you wonder, right? We've gone from boiling animal hides for glue to these incredibly engineered polymers. So as our materials get smarter and our needs get even more complex, what's next? What will the next generation of adhesives that hold our world together even look like?